Hello, my name is Zivyang, and this is going to be my EE104 Lab 8 presentation on the Sleeping Dragons game. So, starting from line 1 through line 5, we're going to have the importation libraries required to run the game. So, import required libraries for randomness and gameplay. So, import math, import random, import PGZ the import random is the feature that we added that puts randomness into when the dragons are breathing fire such that they're less predictable. And then import PGZ run is the PyCame framework that we have to download for this lab from pg0.actor, import actor. That's going to be because we're using two avatars to play this game. We're going to have to use the sprite actors. And then from lines 8 to 12, that sets the screen dimensions and constants. So width is 800, height is 600, center x is equal to width divided by 2. So that sets the center up by dividing 600 by 2. And then center y is equal to height divided by 2. So that's basically setting up the 600 divided by 2. That's going to set your y-axis for the center, and then line 10 is your x-axis for the center. So those two lines set up your center position. So now we have the game settings. So font color, it's a 000 black. So that's going to be the setting up the game settings font that we want. And then the egg target is 20, so that's going to be our number of targets, the number of eggs that we need to win the game. And then hero start, so that's going to be the starting position of the hero. And then hero 2, that's our second avatar that we created. That's one of the tasks for this lab. That's going to be the second avatar that we created for this lab. That's going to be starting position at 600, 300. And then the attack distance is 200, so that's going to be the setting up the distance in which the dragons can breathe fire and attack. And then dragon wake time, that sets up the time when dragons are going to go back to sleep and come back up to breathe fire. So that time is set at 2. And then egg height time, so how long the eggs are hidden after a collection. So as we play the game, we're going to be collecting the eggs, and it sets up how long the eggs are going to be hidden for and how long the eggs are going to be coming up again. And then the move distance, so that sets up the move distance for the two avatars that we created. So the movement speed is based on that line 22 command line. And then we have the game state variables. So we have 3 lives. So these are the initial states for the variables. So game over, that's false. So when it returns a false, then the game is over. Game complete. So when the game is false and it's completed, then we say, okay, the game is not complete, it's false. So we quit the game. And then reset required. So when the game set is false, then there's a reset that needs to be done, and that sets up that up. And then for each of these blocks, lines 32 and 40, that sets up the dragon layer with its own properties. So easy layer, that's going to be the eggs, actor, one egg position 400, 100. And then the dragon actor, dragon as lead position is 600, 100. So this sets up the dragon layer. So each of these functions, easy layer, medium layer, hard layer, that sets up the dragon functions. So as we play the game, the dragons are going to breathe fire and the eggs will pop up. So we need to define the layers, and you could consider them as states as a finite state machine, but it's essentially just a layer. So that's from lines 32 and to 62. So from line 65 to 66, we're listing all the layers that we've declared in the game. And then from line 68 to 70, that's the task that we were implemented. We're going to add a second hero. So that's the creation of the second hero in line 70. And then from line 74 to 91, we basically have the main draw function. And this function enables us to render the game. That's why we need to import the PGZ run and the from pg0.actor import actor libraries, because without that, the game can't run. And in order to set up the draw function, we do need to import that library. And then def draw layers. So this draws layers with dragons and eggs. And then we have the HUD. So as we play the game, it's going to show the HUD that shows the remaining lives and the collected eggs. That's going to be from lines 93 to 98. So it sets up the counters. So screen.blit egg count, that's going to set up our initial count of 0. And as we play along and we continue to collect eggs, that counter will increase. And then from lines basically 101 all the way to 124, that's going to be the main game loop that keeps on looping based on our movements and controls. So for the first hero, we're going to use the arrow keys on the keyboard, but for the second hero, it's the WASD keys that enables us to maneuver around. And then so as we see from lines 106 to 114, it sets up the main game loop. And then that loop is basically telling us, okay, if we input X, then the move distance and the width, all the functions are going to be declared. So it sets up the maneuverability of the game, and it checks the hero position as well as the collisions. So if we collide with the dragon, then it's basically game over. So it sets us up for that. And then the second block, basically lines 129 to 135, that's going to update the layers every second. So as we're playing and looping along, we want the layers to be updated. So that sets up the update function within the code for the game and manage dragons while they're asleep. So def update sleeping dragon. That function essentially basically says that, okay, it has a 5% chance to wake up early randomly. So that's why we have the random library that we've imported. And so once we have the basically the sleeping dragon function, we're gonna have it declare a sleep counter and then sleep length. So it sets up how long the dragon will sleep and how long the dragon will awake. And then that's the second block. The line 150 to 158 sets up how long the dragon will stay awake. So update waking dragon, update sleeping dragon. Those two are different functions that sets up when the dragon is going to be awake or sleeping. And then the egg visibility after collection, that's going to be lines 161 to 167. This function within Python takes care of the egg that's being hidden and collected. So as we collect an egg, the egg is going to be hidden and then it updates it. So the egg is coming back up again so you could collect it. And then lines 178 to 186, this basically checks for egg collision. So as we're colliding and we want to check the egg for collection, so it checks both players. That's why line 180 has 4 player and hero, comma, hero 2. So that's going to check both players and implement the count. So for our egg collision, then it basically handles the egg collision logic as stated. And then the dragon collision, which is lines 189 to 196, it handles the dragon collision. So def check for dragon collision is basically the function that says that, okay, if we're caught, the game is over. So it checks for that. And then def handle dragon collision. So it resets the player positions and reduces lives as we collide with the dragon. So if we're collecting eggs and then we hit a dragon, then we have to reset the player position and it reduces the number of lives that we had before the game is officially over. And then lines 204 to 210, it reduces the life count and check for game over. So it subtracts life. So as we bump into a dragon, let's say our character is dead, then we have to subtract 1 life from the game before it's officially game over. And then lines 212 and 213, this basically says, okay, run the layer update function every second. So clock schedule interval. So that sets up the layer update, which gets updated every second as we play. So, and then lines 216, pgzrun.go, that enables us to just start the game. So now I'm going to demo it. Restart the kernel. And there we go. So it's game over. So if I were to run it again, so WASD is the second player, and then the arrow keys are the first. So I'm dodging and I'm collecting the eggs. So you can even see the count that's being updated, 8, and I have 3 lives. So I can simultaneously control both. And the randomness of the dragon breathing fire is implemented because of the import random. So it's hard to tell if what time exactly the dragon will be updated. And I lost the game. So it's game over. So we can try that one more time right here. So we're collecting the eggs. So it resets and then the game is over. And one final time, just to demonstrate the code's efficiency, let me restart the kernel. So WASD, it move the player along. So we can control both, but I'm using only one character in this case, but we can essentially control player two and player one. So the objective is basically just to avoid the breathing fire of the dragons. So we can move this up. WASD is controlling the second player, and I won. So essentially, just by enabling it to loop through like that, we can essentially ensure the functionality of the game. That has been all. Thank you so much, and have a great day.